Hi guys, welcome to Geek Coding Academy. Today we'll start the series called Advanced Hoops Concept. So we'll see the table of contents. So in this series, we're going to see what is an abstraction and we'll see interfaces in depth and nested and anonymous classes, static keyword, final keyword, and static and final keywords flowchart. So let's start. So we'll begin with an abstraction. So what do you mean by an abstraction? Abstraction is one of the key concept of hoops. We know that, but what do you mean by an abstraction? So the basic understanding of abstraction is nothing but like we need to hide the unnecessary information. Like we need to hide the logic which shouldn't be shared or which is not necessary for other service to implement it. Okay. Suppose if you're driving a car, like if you want to create a function to drive a car, it doesn't need not to know like what is the logic written on engine. Okay. So it should only know the interfaces names, like what should have to be used for driving a car. Like if you're writing a program for self-driving car, so it should know like which class is responsible for braking, which class is responsible for acceleration, and what class is responsible for changing gears. But you don't want to know like internal functioning, how the engine works and everything. So okay, this level of programming is called an abstraction. So why we need to do this? In order to make our code reusable and scalable. Okay, suppose if you want to build any other application, if you make our application such that it's fully abstracted, so it's easy for us to migrate or easy for us to scale our existing application. So instead of tightly coupled, okay, let's see what I mean by like we saw what is an abstraction name. Like let's see how to achieve in our Java code. Either two way we can able to achieve an abstraction. One is through an abstract classes and another one is through an interfaces. In our last video, we saw about how to do abstraction using an interfaces. We saw like how to do a runtime polymorphism using an interfaces. Now we'll see what is an abstract classes. So in our last video, we saw about we go with an interfaces in a case such that all child classes has to implement their own logic. Simply for runtime polymorphism purpose, they need one parent to catch all the child objects. We go with an interfaces. In interfaces, all methods don't have any body. We just write a method signature. Okay. Up to at least up to Java 8. Like in Java, after Java 8, there are some modification, but up to Java 8, like in interfaces, only a method signature will be allowed. Okay. But suppose in our use case or in our requirement, we need a class, a parent class, such that at least some of the method is generic for all the child classes. In such cases, we can't go with the interfaces because interfaces we don't give a body. So such that what we can do is we can write a class where which all the generic methods we can give a body, which are all not generic or which are all required a specific logic to be written by a child class, then we can avoid writing a body for that method. Okay. That is allowed in Java. So in order to, if you not give a body to any method, you have to make that method as an abstract. Okay, let's see the syntax, or let's see the first we'll see the key points what a abstract classes is. So if you make any class as an abstract, that means you are telling in a compiler or you're telling in JVM that in this class some of the method don't have a body or one or more method don't have any body. So in that cases you can't create an object for that class. Obviously, like you can't create an object because your methods are not completely written. It's just only declared, logic will not be there. And an abstract class can have both abstract and non-abstract methods. As I said, it can have both like a normal methods where both declaration body will be there and some of the method only declaration will be there. Because those method child classes should give implementation because that's specific to child class. So can have a constructor and fits because it's a class, it will have a normal class behavior. And this is used for partial abstraction. Why partial abstraction? I told you like some of the method we written in parent class, so that will be anyway exposed. So that's the reason it's a partial abstraction. If you use an interfaces, you can achieve a full abstraction. Okay. So it all depends on our requirement. Okay. Let's see the syntax. See, I declared a class called animal. I initialized one field, a string of name, and I created one more method called sound, which is returning type is void, means that doesn't return anything, but I'm not giving any body here. So what I can have to do is either I need to give a body or I need to label it as an abstract. So this is an abstract method. That means as a parent class, I don't have a generic solution for this. Our child class, whichever extending my, should give a body to it. Okay. This is one abstract method. So any abstract method, if a class has, then we need to make a class or we need to label the class as an abstract. Okay. And one more method we have like sleep, which is also written nothing void. But here I'm giving in a implementation because sleeping. This is a generic solution. Like all my child classes belong to the animal under this animal parent. We'll do only sleep. But sound varies, right? Like dog will sound differently and cat will sound differently. That's the reason we make it as an abstract method and we make this as an with implementation. That is a concrete method we called. We'll say. So extending an abstract classes. It just like in a suppose we already saw in our inheritance concept, guys. Like if you are not watched the inheritance, please watch that video prior to this. We already saw in inheritance, like if any classes extends another class, then that class become a child class of that extending class. And the extending class, which class provide like which is if child class extends another class, the other class will become a parent, and this extending class will become a child. Okay, this child class will have all the methods, fields from its parent by default. And if they want, they can override the existing logic, or if they want, they can keep it child class. So this is the concept of inheritance. But here, what happens if we inherit the abstract classes? Because some of the methods don't have any body. So if you are extending that an abstract class, then it's a child class duty to give a implementation. Okay. So here, dog, which is extending animal. In animal class, we have a one concrete method as sleep that has a body, and one more method called sound, which doesn't have any body. So that's why we have to give implementation here in our child class. Okay, we have to provide an implementation. If you not provide, then we need to make a child class as an abstract. And if you make any class in abstract, you can't able to create an object for that because that's an off. That's like without implementation, how can create an object? Because you can create a blueprint, but if you are constructing something that should be there, like all logic should be there. Okay. So what do you mean by an abstract method? We'll see it in depth. So yeah, one more class I created as shape. I created one more method as draw, which is of type abstract. Means I don't have any body for this. Then I have to make class as also abstract. So one more class circle, which extends shape. Means circle is a child class and shape is a parent class. So here, this draw method, I have to give an implementation. Okay. An abstract method is a method that is declared without an implementation. When a class contains an abstract method, then class also should be declared as an abstract. Key points is no method body. In abstract class, there is no method body like some of the method and must be implemented by subclasses, which is already I told. So, okay, you have a doubt like we have an interface, sorry, when to use an abstract class and methods. Okay, you can ask. It depends on requirement. Like suppose uh, we need a parent class just to hold the reference of a child classes. Suppose we need to create an animal class as an abstract such that all objects or all classes coming under this animal class we can able to catch using the parent class reference such that we can achieve complete abstraction, or some of the methods is generic for all the child classes we can able to declare in the parent class. Okay, such that we can achieve like partial abstraction. Okay, and also we don't want to create a parent class object. In that case, we can go with an abstract classes. If you're confused, like I already told, like interfaces and inheritance concepts, please watch that video prior to this. Okay, and when you have a method, suppose I have a method, I can't give a generic implementation for that. So what I can do is I can make the method as an abstract. So instead of giving an implementation unnecessarily, and even child classes can override that method, instead of that, what I can do is in a parent class, I don't give in a body because that is not generic solution. So I'll make it as an abstract method. Our child classes should has to give a body to that. Okay. Okay, you can now you have another doubt like what is the difference between abstract classes and interfaces? We have already in interfaces where we don't write a body. We just declare a method signature, but in abstract classes, we are doing the same. In class level, we are doing the same. We write the class definition. We are not giving in a class body. Sorry, method definition, and we are not giving in a method body. Like, what is the difference? There is some difference. In interfaces, we can't able to write so all the methods we declare under interfaces should be only declaration. There is no body up to at least for Java 8. Like after Java 8, there are some modifications done, but up to Java 8 in interfaces, only a declaration will be happen. There is no body for method. But in abstract classes, it's not like that. In abstract classes, any one of the method don't have any body. Some methods may have any body. So there will be like advantages for child. So if he has a generic, it will use the generic methods. If he has its own specific methods, those are abstracted anyway in the parent class, so it will write a logic to it. Okay, and a class can extend only one abstract classes, but it can extend multiple interfaces. It can only extend one abstract classes? Because abstract or non-abstract class is a class, and in Java, multiple inheritance is not allowed in order to avoid diamond shape problem. Okay. So if you are trying to extend, suppose like one child class, it trying to extend both the parent class A and B, if same method present in both the classes, okay, when you try to call that same method in our child class, you'll the compiler will go into ambiguity like which method should be called, or like there is a diamond shape problem. It will go into a loop. So in order to avoid that, in Java, like one child class can have only one parent, like that. But in interfaces, anyway, we don't have any body for that. If you defined on both the classes, like it will be like only a declaration. So child has to provide an implementation. So in interfaces, a multiple interfaces are allowed. Okay. So the concept of this abstraction came into picture because of reusable code. We need to define a reusable code and scalable application. Okay. By focusing on object like what it should do rather than how it is done. I'll tell you an example. Like suppose I have an animal class or animal interface as an entity, like one thing, parent, under which I have a all thousand or 2000 list of animals, which are all child, which are get connected to this animal. So suppose I'm building an application, I don't have to go each and every individual classes like cat, dog, human, etc., etc. I don't have to go and validate, or I don't have to remember all the child classes in our main program. Just I'll write this parent class reference animal, and whatever object comes, the animal reference will catch it. Okay. So I'll write only the logic by keeping in mind that animal. Okay. I don't want to know like in animal what types of object or what all the child classes may have. I don't need to worry. I just have to consider only an animal reference. These animal reference anyway they catch its child class references, right? So I can at runtime like this animal, if there is a cat object is coming, it will catch it. There is a dog object coming, it will catch it. So I'll get a lot of like abstracted, so I don't have to go tightly coupled my program. Instead of that, loosely coupled, I can able to do it using an abstraction concept. So suppose tomorrow, if I want to do any modification, just I'll change with the main program with an animal references, not with the individual. Okay. So these will make our application more reusable and scalable. Okay. So this is all about theory, guys. Let's see code. So I created a one Java class called abstract demo, where I created a class called an animal too, where I don't give a I created one more method called sound, which is of type nothing. means is returning nothing. So I make it as an void, and I'm not giving any body here because I'm creating an animal class, animal parent class, where sound, like each animal has its own sound. So I don't think giving in a solution for this is a better idea, because child classes should have its own implementation. So I make this as an abstract. Means I'm not giving in a body to it. I'm just defining it as an abstract. If any one of the method is abstract, I just has to make, just has to label a class as an abstract. Okay. And I'm having one more concrete method as sleep. So I think all animals will sleep. So this is generic. So I'm giving an sleep. So later I created one more subclass called dog one, which extends an animal to, like, which is my parent class. And it has to, like, here in dog, like, I use constructor to initialize this dog one object, where name of the like name of that belonging, just give here. So name means like dog name or anything. Okay. Here I have to give an implementation for the sound. Okay. Here you can see I'm overriding in a sound because sound doesn't have a body, because it is an abstract method. So I'm just overriding it here, sound. I'm creating it box because dog box with the name and box, like name of a dog or its box. Later I created one more subclass called the cat one, which extends an animal too. Here also I'm initializing cat one name during the object creation through constructor. This is a parameterized constructor. After that, I'm just overriding the sound because this sound is unique. Like it's specific to a child class rather than an animal class. So yeah, that's this all about. Like in our main class, there is a public class. I already told, like, there will be one public class where the control will enter, and there will be a main method. In a public class, it should be a main method with of type public static of void. This is where control will flow. Control will enter into the program. So I creating an animal class. See, this is a I created a dog object which name as a buddy. Dog name is buddy. See, the reference is animal. The dog object catched by an animal reference. This is what an abstraction is. This is what runtime polymorphism is. After that, I just invoke a method, sound and sleep. This sleep method is coming from parent class because it's generic. The sound is coming from the child class because this is child specific. After that, I create one more CAD object where I created in the CAD object, and this reference is catched by this animal. So see, both animal references can catch different types of an object. This is what an abstraction is. Okay, the cat that sound is coming from the child class. I just give whisker as a cat name, and cat that sleep, it's coming from a parent class. Let's run the program and we'll see. As you guys say, buddy box. I just give the dog name as buddy, and it buddy box initially, and buddy is sleeping. Then whisker meows, whisker sleeping. So yeah, this is how it is abstraction, guys. So thank you for watching. I hope you understand what is an abstraction, what is fully or partially abstraction, how to achieve an abstraction using an abstract classes and interfaces. In our last video, we talked about interfaces also. In our coming video also, we'll talk more on interfaces in depth. So if you like this video, please share this video to your friends and colleagues, and please subscribe to my channel. And thank you for watching. In our next video, I'll come up with a more advanced concept. Till then, keep watching, keep learning. Thank you. Bye.